A. We love math A. We love math A. Every time we divide, we already know the path A. Then we multiply, all we gotta do is roll the die A.
Hey math lovers, let's go over lesson 1.4, solving quadratic equations by factoring. Just to give you an idea, remember, solving quadratic equations, just give you a quick picture on the coordinate plane. We're trying to basically just solve for these two blue dots. That's what solving means, right? We're solving for the roots, x-intercepts, the solutions. And we're going to do this specifically by a method called factoring. Standards for mathematical content, we're going to solve quadratic equations with real coefficients that have complex solutions. Extend polynomial identities to complex numbers. Right? Don't forget those pirates. Aye. And use the process of factoring completing the square in a quadratic function to show zeros. Remember, zeros is another way of saying those blue dots. And extreme values. And symmetry of the graph, and interpret these numbers in context. Well, how can you meet these standards? I can use factoring to solve quadratic equations and real-world problems that have real and complex solutions. Okay, let's go on to this next part called Standards of Mathematical Practice. How can I use these practices? Well, mathematical practice number 1, make sense of problems and persevere in solving them. I can solve quadratic equations by factoring and then check my answers by using a different method. Mathematical practice number 7, look for and make use of structure. I can look for patterns and discern a structure for factoring quadratic equations. All right, what is our learning targets here? In this lesson, all right, learning targets in this lesson, students will be able to learn how to solve quadratic equations by factoring. By the end of this lesson, students will be able to answer the following questions. What methods are used to factor trinomials? Number 2, how can quadratic equations be solved by factoring? And number 3, what's special? What special products can help solve quadratic equations by factoring? All right, let's see what you know. Let's see if you can factor. I have 5 questions over here in the warm-up. Go ahead and try those, and then go ahead and press play if you need some help or you're ready to check your answers. All right, so before I go over the warm-up, it might just be helpful. How do you factor quadratic trinomials? Here are some steps. So step number 1, set equal to 0. You basically want everything on one side of the equation. Number 2, I want you to look for the greatest common factor. And there might not be a greatest common factor or GCF, but what it does, it makes our quadratics or a polynomial smaller. Number 3, put it in standard form, which we learned last lesson, in lesson 1.2, which is ax squared plus bx plus c. Step number 4, identify the a, b, and c. Number 5, the x. You're going to have a times c on the top and b at the bottom. Number 6, I'll put over here, you're going to do the box. And the box looks like this. And what you put inside the box I'll just use the above one as a help. You're going to put ax squared always in this part right there. Something I forgot is that you're going to find a number and you're going to get in purple here the product. Product means to multiply those two numbers to get A times C. And those same two numbers, you will get the sum, or you add them together to get B value. Okay. Once you do that, you will take these two values and put them here always. So I'm just going to write something x, something x. And then you're always going to put your C value here in the bottom right. So if you go back to standard form, basically what you're doing there is you're taking these and putting them in here, and that's how you're going to fill out your box. And then number 7, binomials. And you get the binomials that are on the outside here. Your answer will look like this. Okay? Alright, so this is called the area model of factoring using the X box method. You'll notice there's an X and there's a box. Okay. Question number 1. Set it equal to 0. You'll notice there's no equal sign, and basically everything is on one side of the equation, so you're done. The next thing is you're going to find the greatest common factor. You'll notice that this is m times n, and this is m times n times w. Now, you'll notice that they have a what in common? An m, and they also have an n in common. So we call this to factor out. I'm going to have this m and this n on the outside. Now pay attention. In the inside, up here, there's nothing left, so I'm going to put a 1 here. So that would be 1 plus, there's the plus, and then this one is not, is left. So here in this problem, all I had to do was just the greatest common factor. Alright, to check my answer, you can do something called distribute. So you can take this, mn times 1 will give you mn. Mn times w will give you mnw. So all I had to do in this problem was factor out the GCF. Okay? I want you to notice something. This method, for question number 1, does not apply to how do you factor quadratic trinomials. Trinomials has 3 spots, 1, 2, 3. It is also quadratic, so it has a power of 2. You'll notice that this question here had no power of 2. Okay, let's look at number 2. This one is a perfect example. We're going to set it equal to 0. So it's already on one side of the equation. You can just put it equal to 0. And here they're just asking us to solve. I'll tell you about. They're asking just to factor. Okay. They have nothing in common, right? X squared, 4x, and negative 5. It's already in standard form, but what I'm going to do is identify the A, B, and C. We've done that before, right? So we can say A is 1, B is 4, and C is negative 5. Remember, that comes from standard form. And the coefficients A, B, and C never have an X on it. Okay, so we've done that. Now we're going to have to do this box method, okay? The X method first. So A times C goes here, and B goes there. So A times C is negative 5. My B value is just 4. Alright, so now I need to think of two numbers. Those same two numbers, when I multiply them, they are negative 5, but when they add together, their sum is 4. So let's say I pick 5 and 1. 5 times 1 is positive 5, so one of these has to be negative. So I'm thinking that this is negative 1. 5 times negative 1 is negative 5, but 5 plus negative 1, or 5 minus 1, is 4. Okay, next thing I'm going to do now is put it into my box. You have it previously, it did not save, somehow my iPad crashed. Thank you very much, iPad. And let's go ahead and put it here. Okay, so let's use different colors. You will always put this term here in the front, always. So not ax squared, but in this case will be just x squared, okay? This bx term is these two, so 5, and we're going to add an x, and negative 1x, okay? And you'll notice it goes back up to the original one up here. 5x minus 1x gives you 4x. And then the last thing is negative 5 will always go out here. Okay, what I'm going to do here is I'm just going to take out the greatest common factor. So what do they both have in common? They both have an x in common. Let's go down. 5x and negative 5 have something in common. That is a 5. If I go up to the top here, I'm trying to think of something of the column up and down, x squared and 5x. What do they have in common? They have an x in common, and negative 1x and negative 5 have a negative 1 in common. And the cool thing about this is you can use this to actually check your answers. X times x equals x squared. X times negative 1 equals negative 1x. X times 5 gives you 5x, and 5 times negative 1 gives you negative 5. Okay, so my two answers are actually out here. Whoa, too bright. Are out here on the outside. So when you factor that, you will get x minus 1 and x plus 5. Now the order does not matter. So we just factored x squared plus 4x minus 5. Now I want to open this up. If you were taught a different method, totally use that different method. Guess and check, hockey sticks, tic-tac-toe. There are a bunch of them, but I'm just showing you one, and if you're going to use my method, keep using it. Okay, question number 3, we're going to do the same thing. Ax squared plus bx plus c. So a is 2, b is 9, c is 4. I'm going to put it into my x in my box. Okay, so I have a times c here. So a times c, so 2 times 4 is 8. My b value will always go down here, so that is 9. Two numbers that multiply to be 8, you can think of them as 8 times 1 and 4 times 2. And my two numbers are going to be 8 and 1. 8 times 1 gives me 8, and then if I add those two numbers together, they give me 9. Okay, let's go ahead and put in these now. This term will always go in the top left. The red ones are really this. See it? So 8x and 1x. And you remember what always goes in the bottom there? Yeah, this one, the plus 4. Okay, let's take out the greatest common factor now of each row and column. This one has an x. Going down, this one has a 4. The column has a 2x, and this one has a 1. So these are going to be my answers right here. Just put it up here. 2x squared plus 9x plus 4 is the same thing as 2x plus 1 and x plus 4. And we'll go over and practice more details later of each of these. Question number 4. This one is missing a middle term, so I'm going to add 4x squared plus 0x minus 25. That means my a value is 4, my b value is 0, and c is negative 25. Now the reason why I added again as 0 is because you'll notice that negative 25 is not the b value. The b value has an x attached to it, but this one does not, so you can have a 0x there. Alright, let's do our x and our box. Okay, a times c, so 4 times negative 25 is negative 100. My b value is, we'll always go down here, is 0. Okay, two numbers that multiplied would be 100 or negative 100. So you can put up the factors up here. Alright, which one, if I add them, will be 0? Now, to get 0, you're going to have one positive, one negative. Let's check. Positive 10 times negative 10 gives you negative 100. Positive 10 plus a negative 10 gives you 0. So that is the correct answer. Okay, the a always goes up here, so 4x squared. The red one is our b value, so you'll notice that 10x and negative 10x is equal to 0x. And negative 25 is my c value, always goes in the bottom right, always. Okay, here now, we're just going to take out the greatest common factor of each row. A row goes left and right, so this would be 2x. Down here, this would be a 5. In the column, it would be 2x, and this one would be a negative 5. Let's double check our answers. 2x times 2x gives me 4x squared. 2x times negative 5 gives me negative 10x. 2x times 5 gives me 10x. And 5 times negative 5 gives me negative 25. So these are my answers right here. Put it right up here. Why? Because you factor 4x squared minus 25, you'll get 2x minus 5, and 2x plus 5 is our answer. And the last one, a is 25, b is negative 30, and c is 9. Let's do our x in our box. Okay, a times c is 5 extra 4, 225. So a times c. My b value always goes in the bottom here, negative 30. So I'm going to write out all the factors of 225. So this is a great strategy when the numbers are big, you can't see it. Okay. How about, how many 25s in $2.25? So 4, 8, 9. 15, I believe. 15 squared. Oh, I think I got a winner. But how do you add them to get negative 30? Well, that means because they're both negative. Negative 15 times negative 15 is 225, and negative 15 plus negative 15 is negative 30. Okay, so that means my A value always goes in the top left. Always. My B term is now split between these two, right? Negative 15x and negative 15x. Basically, if for those who are more advanced or know how this works, this is actually factoring by grouping, the box method. Factoring by grouping. And this last one here always goes on the bottom. All right, let's go ahead and take out our greatest common factor in this row. That would be 5x. This one's got to be negative 3. 5x, and what do you think? Negative 3. Now, if you think about this, let's double check. 5x times 5x is 25x squared. 5x times negative 3 is negative 15x. Negative 3 times 5x is negative 15x, and negative 3 times negative 3 is positive 9. Okay, so if I get these answers, 5x minus 3 and 5x minus 3, well, pretty much they're the same. And if they're the same, you basically have how many of those? You have 2. So we can say 5x minus 3 squared, okay? And that's the warm-up. Sorry, I didn't say question number 1, but you can just rewind there. All right, let's talk about our vocabulary words here. In our vocab, a form of quadratic equation, 0 equals a times x minus p, that one should say x minus q, where a is not equal to 0, in which p and q are x-intercepts of the graph of the related function. This is called factored form. Factored form. And I'm going to put a big star by this. I don't really use stars, but we've only had another form. The other form that we've had so far is standard form. So now we have 2 of them, standard form of quadratics and the factored form of quadratics. I also want to point out that it says P and Q are x-intercepts of the graph. Oh, I did save it. That's what I was talking about. There's my x-intercepts right there. Okay? That's all we're doing. All is finding those 2 dots. Crazy, huh? Okay. A binomial. So what is a binomial? A binomial is basically a parentheses, has something like this, x minus something. Up here you see 2 binomials. A binomial in which first and last terms are perfect squares. Okay, this is called the difference of squares. And it basically looks like this. So I have 2 binomials, 2 sets of binomials, and it's kind of like, not conjugates, but the same idea as conjugates. One is a positive, and then one is a negative. Okay, those are called difference of squares. If you want to see a visual why, these are called algebra tiles. So if I do this red box, x times x is x squared, and then if you did okay, say the green ones are negative 1s, so that basically represents negative 3. And then if you did positives over here, I'm sorry, these are positive 1x's, and this is negative 1x. This is negative 3x, so a positive 3x and a negative 3x will cancel, so that's gone. And basically what we're doing is then we're finding out this is like a square. I don't know if that makes sense. But this is the conceptual of factoring. You'll notice it's kind of like the outside of the box, and x plus 3, x minus 3. No, those are supposed to be just positive 1s. And everything's disappearing, but hopefully you get the idea. Okay, what's the squares of binomial? This one, the answer is perfect square trinomials. And that was warm-up number 5. Warm-up number 5. Difference of squares was the plus and ones minus. That was warm-up number 4. And all of those were factored form, questions 2 to 5. Okay?
From Savannah High School, Mr. Math Ang, giving you game plans and teaching you stats and probability so you can use it in the real world and while dominating in chess.